All right, let me share this. Da, 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 da. So I have slides for you all. We're gonna go this way, the other way. So I was in charge of coming up with all the scripts for training the models, and then the file structure and how that would all work in the back end before it even goes into the API, making sure that all the models were training and nice and accurate. So there's a bit of a basic file structure that goes into it. In our environment, we have a models, Python files, and a photo data, 3 folders, and it's infinitely scalable. Models are stored in your models folder. Your 2 scripts are stored in your Python's folder, and then all your data goes in your data folder. As long as your data is stored in appropriately named folders, you can go as big as you want. All you need to do is dump more data in there. And when you go to train your model, it'll give you the option to retrain models or to only train off of new data. It's going to use all the data it's been given, whether it's it's going to use all the data you give it, and you can specify a minimum amount of data that a model can be trained off of. We were using 50 because that seems to be a good amount of like data entries given the amount of data that Ghent gave us to start off with. There were a couple challenges along the way. Data quantity was a big one. We got web scraping working, but data quality was rough. So a lot of that data had to be axed. Model complexity, keeping it low, but keeping the models accurate is tricky. And then surprisingly, when getting results from the models, loading models onto the GPU version of TensorFlow was a surprisingly big slowdown. Nothing deal breaking, but longer run times than you might expect from loading something off of a pre-trained model. But again, the scale of it is very scalable. I have a photo that I can share as well of a heat map that you can generate using the diagnostic script. We're looking at around 70% accuracy with lower ends of data, and then upwards of 90% accuracy for stuff that we had more data for. Overall, really good turnout. The only thing that needs to be done to make the models more accurate is we could institute image cropping. We weren't able to get that 100% working by the end of it. Unfortunately, we got close, but we didn't get it quite ready. More data. When we hand this over to Ghent, all he needs to do is plug in more data into the datas folder and retrain some of the models. Be great. And then something that was really interesting that we brought up but didn't have time to implement is in the back end, when you add more models to the models folder, instead of having to take down the whole website and then relaunch it to load up all of those models, making it so that the models are dynamic. So you don't have to take everything down in order to expand the system. So you can see here the scripts. It specifies some data paths, some image size, some small sample size, and then it goes through and it runs everything. It's in a pretty modular form here. It's even a little bit more object oriented in the API itself. And then for diagnostic data, you have a couple options. You can get either just the top predictions for an image that you pass in, or you can go through and use all of the data to get diagnostic info on all of your models, depending on what you need to do. And then that is using multi-threading to speed it up just a little bit. And I think I'm going to pass it over to AJ now to talk about what's going on the back end of things.
Yep. So I'm going to be talking about our
see.
API, and I'm going to be giving a live demonstration.
Really quick, a little embarrassing. Oh, never mind. I found it.
Okay.
Stop share button.
Okay. So first of all, why we chose to make an API. APIs are very flexible. It will allow us to access our plant images with just a simple HTTP request. And this means we could build many applications on top of it without having to worry about like cross-platform issues or anything like that. It's also very scalable, as Casper mentioned. And the separation between the API and the client requesting it means we can make a lot of changes to the API and optimize its performance without impacting the client. And lastly, it's secure. We could add authentication to the API, and a client requesting the API can get compromised without the API's security getting influenced. So a little bit about how it works. So we use Flask for this, and it allows us to implement our models with the API. So when the API receives a post request, it will call a function that gets the model predictions and then returns the JSON format of the top 3 predictions. You can see the code right here. And more specifically, the predictions, as Casper shows, it goes through all of the different models, and then it will return a ordered list of the highest to lowest confidences of the plant species. So this is how you'd interact with it, or an example of how you'd interact with it. You could do something like just sending a simple request using Python. So I'm going to show you that. So on the left, we have our API running. So this is the code I showed, and you could see that it's live and accepting requests. And I have a simple website that just sends the request to the API. And keep in mind, the website is totally isolated from the API aside from that request. The API runs standalone. You can make any type of request to it. And this website's just a way of interfacing with it. So I'm going to show you, we have the website here, and I have this image. So I'm going to upload it and submit it. And as you can see, it returns the top 3 predictions. So here, it also prints them out, and you could see it sent a post request to the API, and upon receiving that post request, the API was able to return its predictions. And you could also, as I said, I have the image right here in my directory. So I could also just include that image in this function, which is ideally what you do if you're running a script, and just request the API with the Python request module. And as you can see, it returns a JSON output of the responses. So that's a demonstration of how our API works and the backend.
And for me personally, during this course, during like my time with these guys, I learned a lot more about Python than I knew coming into it. I learned a lot about APIs and web scraping, and it's honestly been just a fantastic experience. If I could do it again, I absolutely would. These guys were all the best.
Absolutely. Sorry, I muted myself and didn't get a chance to say. And now, Evan, talk about your experiences. But thank you, Evan. And then Casper, if you'd be so kind, similar situation.
Yeah, so this was really, really cool. I learned so much about image processing going into this. I had been coming from the NLP side of things from summer, and just first off, just getting more comfortable with Python, learning more about how to interface with models that use photos, what all the challenges are involved in that, and then also just making sure that like I learned how to like format code in such a way that it is like acceptable for people to like read, and is like clean, and people will not be completely disgusted by it when they look at it, which is an improvement. It was really just really awesome. I really enjoyed working on this whole project. It's fun to work with the team, and it's really, really cool to see it all come together in the end.
Awesome,
Yeah.
awesome. And then AJ, a couple words.
Yeah, so I mean, I obviously plan on going to computer science in the future, and I would say this program improved my skills and honestly kind of set me down that path. It like solidified my my liking toward computer science. I learned a lot, like specifically in the beginning, we were pre-processing this like large data collection. I got to see like actual scraping of like thousands of images and getting to process those. And then I got to connect it all by making a backend that actually sends requests to Casper's models and gets to make those predictions with those images I collected. I also learned a lot about teamwork. Like I've never really worked with like, you know, like a full team and like collaborated and combined our different code and ideas. But this is one of the first times I got to do that. I'm very, very grateful I got to do so.
Fantastic, fantastic. And then William, if you'd be so kind, a couple words.
Yeah, so yeah, so I have a bit of a cough, but one of the biggest things I learned from this camp was or this incubator was just to not overthink about things, because I kind of spent a good amount of time in the cropping tool, like running in circles trying to figure out whether or not I should be having multiple H5 models to like store images and stuff, like similar to like how Casper does it. And after I was just like, it's just like after like one day, I just like came to Karen. I was like, yo, how should I be like storing these images? And he's like, oh, you just gotta have them all in one folder. Just one folder full of just general plant images and one folder with no image, with like no plants in it. That's all you gotta do. And yeah, after hearing that, like, and I can, like, it's more clear to me now how to complete the tool. And so a good part of a good reason why like the tool is not here today is just because of like how I've been just like going in circles and like.
Yeah, but it sounds like, you know, like
You
you've
got something.
identified some steps towards improving that. So, you know, and shout out Cameron for you know, the support there. And, you know, it goes to everybody here. You guys are always going to have, you know, the support group of the AI Camp, you know, community Discord, and you can always ask questions in there when you're spinning your wheels or feeling stuck.